Hey guys, in this video we're going to talk about 1.4 to 1.6. These sections in AP Precalculus are based on polynomials, but I have selected a couple of hard questions over here. You can download this worksheet from the link in the description, and if you need private tutoring, feel free to reach out. Right, we are given a polynomial over here, and we have to find the values of the constants p and q such that x minus 2 and 2x plus 1 are the factors of fx. Okay, so if these two are the factors, can we say that x equal to 2 and x equal to negative 1 half, or maybe if that is not making sense, 2x plus 1 is equal to 0, so 2x is equal to negative 1, and x equal to negative half is, these two are roots. Can we agree on that? So there are two ways to do this question. Either you can perform a synthetic division with x minus 2 and set the denominator, set the remainder to 0, and then perform a long division with 2x plus 1 and set the remainder to 0 of the other factor that you're getting. But I think what I'm just going to do is a very simple approach, that I'm going to plug in 2 here and negative 1 over 2 here as well instead of x, and I should get 0 because that is the meaning of roots. Remember that all these calculators all these questions are no calc questions. So if I'm going to plug in 2 over here, so that's going to look like 2 times 2 cubed minus 9 times 2 square plus 2p plus q should be equal to 0. 2 cube is 8, 8 times 2 is 16, 2 times 2 is 4, 9 times 4 is 36, plus 2p plus q is equal to 0. 16 minus 36 is, I think, negative 20. And negative 20, when 20 is added on both the sides, this is going to look like this. That's my first equation. I hope this makes sense. We're going to keep it aside. Now I'm going to put negative 1 over 2 over here. So this is going to look like 2 times negative 1 over 2 cube minus 9 times negative 1 over 2 square plus p times negative 1 over 2 plus q, right? And that should also give me 0 because, once again, these guys are the roots. So this will become negative 2 over 8. This will become minus 9 over 4. This is minus p over 2 plus q is equal to 0. 2 times 4 is 8. So negative 1 over 4, negative 9 over 4 minus p over 2 plus q is equal to 0. Negative 1 minus 9 is negative 10. Negative 10 over 4 can be written as negative 5 over 2 minus p over 2 plus q is equal to 0. Let's add 5 over 2 both the sides. So negative p over 2 plus q is equal to 5 over 2. And let's multiply 2 both the sides so that it will become negative p. The mistake that students usually do in this step, if they multiply 2 both the sides, is they write this, which is not correct, because if I'm multiplying 2 both the sides, don't leave this guy alone. The 2 will be the 2 will be multiplied to everything. So this guy will also become 2q. That's my other equation. So all I need to do is solve these up. So back to algebra 1 things, where probably I will use elimination or substitution. Let's use elimination. So the other equation I'm just going to write right below this one and multiply this equation by 2. So this is going to look like negative 2p plus 4q is equal to 10. And then I'm going to add these two equations. So 2p minus 2p is 0. Q plus 4q is 5q, and 20 plus 10 is 30. So q is equal to 6. That's what I'm getting. And if I want p, then I can sub in this q over here. Negative p plus 12 is equal to 5. Subtracting 12 both the sides, it's negative 7. So p is 7. So these are the values of p and q. Hope this makes sense. The next question that we have is, there is a cubic polynomial where b is a non-zero constant, and this means that x is an element of R. It means that its domain can take any real value. Anyway, if fx can be expressed in this form, where a is also a non-zero constant, then what is the value of a and b? Right, guys, those of you who are preparing or will be preparing for SAT, this question is very much relevant for the SAT prep. But at the moment, we're just going to do keeping AP Precal in mind, because in SAT we can use Desmos and all, but right now this is a no cal question, so let's try to see how we can do it. Okay, what I'm gonna do is I'm gonna open this up. Now, I don't know how many of you guys know the formula for the expansion of a minus b whole cube. I can write that over here for you. A minus b, or x minus y cube, is x cube minus 3x square y plus 3xy square minus y cube. That is the formula. So keeping that in mind, I'm going to open x minus a whole cube, which is going to be x cube minus 3x square a plus 3xa square minus a cube. And then there is a negative 4 as well. So let's write this complete thing, negative 4. And this is nothing but this, because they are saying that fx is written in this form. So it's just a different way to write it. But after all, these two guys should represent the same situation, right? So if I compare these two now, compare as in if I say that this x cube and this x cube must be equal, which they are, it also means that the x squared terms should also be equal, right? These x squared terms should also be equal. So look at the coefficient of x square on the top. Coefficient as in everything other than x squared that is multiplied with it. It's negative 3a. And look at the coefficient of x squared at the bottom. It's negative 6. So these two should be equal, right? That is the aim, because then only these two equations will correspond to the same thing. So from here I got a as 2. And likewise, look at this b. Or you can compare it doesn't matter, it doesn't make any sense to compare this because we already got a. So let's compare the constant and make sure that you capture this entire thing, because this entire thing is behaving like a constant. So these two should also be equal, negative a cube minus 4, and that should be equal to b. A cube, 2 cube is 8, 8, negative 4 is b, so b will be negative 12. So this should be the value of a and b. Right. If you have a cubic polynomial and it is given that x equal to k is, if it is divided by x minus k, then its remainder is negative 4, then what are the possible values of k? I think I can use synthetic division over here, right? So I'm going to perform a synthetic division. I hope you guys know how to do it. We set up only the numbers, which are the coefficients or the constants. So I'm going to write 1, negative 9, 24, and negative 20. And this x minus k is equated to 0. And I'm going to get x is equal to k as the number by which I need to perform the synthetic over here. Okay, so if I do that, then I think I'm going to have k over here, and synthetic division suggests that this number drop dead as it is, so 1 comes down. 1 times k is k, you write k over here, and then you add these two things. So if I add these two things, this is going to look like negative 9 plus k. This negative 9 plus k, I'm going to multiply back to k. So I'm going to have negative 9k plus k square, and I'm going to add these two things. When I add this, will become 24 minus 9k plus k square, and I'm going to multiply this again back to k, and this is going to look like 24k minus 9k square plus k cube, and I'm going to add these two up again. So this will become 24k minus 9k square plus k cube minus 20. I could have used remainder theorem as well. I'm just not using it because that's not a part of AP Precal. So I'm not really suggesting you to, know another theorem that's more of a part of Algebra 2 or SAT. That's why I'm using something that is used in AP Precal. Anyway, now this guy is the remainder, right? So, and this guy is equal to negative 4. So let's do that. K cube, I'm just writing as a standard form, minus 9k square plus 24k minus 20 should be equal to negative 4. So k cube minus 9k square plus 24k, we add 4 both the sides, so it will become minus 16 is equal to 0. Unfortunately, this cannot really be factored as easily. So I'm going to do a hit and trial method or something that is called rational roots theorem. Um, uh, this theorem is usually covered in school, rational roots theorem, as a part of the AP Pre-Cal course. So I hope you guys know it. If you don't, then just let me know in the comment section and try to explain it. But in the rational roots theorem, what we do is we take the ratio of the leading coefficient, the factors of the leading coefficient, sorry, the factors of the constant. So the factors of 16 over the factor of the leading coefficient, all the possible factors. So this gives me possible roots of this rational function, of this equation. So that will be factors of 16 will be 1, 2, I think 4, and then 8, and then 16, and here we just have 1. So possible roots are plus minus 1, plus minus 2, plus minus 4, plus minus 8, and plus minus 16. And we can just try the easy roots and see if it works. I'm going to try k equal to 1 first, and let's see if it works. So if I put 1 here, I will get 1 cube, that is 1, then minus 9 plus 24 minus 16. And this is 25 and this is minus 25. So yes, I'm getting 0. So we just wanted one value of k. So yes, k is just 1. That's our answer over here. Okay. Over here, they're saying that let P be a polynomial of degree 6 with real coefficients, and P has exactly two distinct real zeros. P has exactly two distinct real zeros, one with multiplicity 1 and other with multiplicity 2. Okay, so they are saying that the degree is 6 and they have two real zeros, real 0, 1 and another real 0. One real 0 has a multiplicity of 1 and other real 0 has a multiplicity of 2. So in a way, the same thing is appearing twice, right? So real, real, real. That's how the situation looks like. So I have three real roots in a way. One is repeated. That's a different point. So how many complex zeros of the form a plus bi with a greater than 0 and b less than 0 can p have? 1, 2, 3, and polynomial does not exist. This question is based on the property of the complex conjugate theorem. And the complex conjugate theorem suggests that complex numbers always occur in conjugate pairs. In other words, the complex numbers are always even if we count all of them because they are occurring in pair. Now, as per the fundamental theorem of calculus, if the degree of the polynomial is 6, then the total roots, including real, including their multiplicity and imaginary, will also be 6. So by that logic, there should be three complex roots. But is that possible? No, because we just agreed that the number of complex roots are always even because of complex conjugate theorem. So actually, no such polynomial exists that it can have three real zeros and a degree of 6. That's just not possible. Okay, here we are given that for which of the value of k is this guy odd function. I hope you remember the definition of odd function. Odd function says that f of minus x is minus of fx. Guys, I'm just going to tell you a very neat trick to solve this question, right? In fact, to solve any even odd question. In a polynomial, if all the powers are odd, look at that, there is no power of x, which means that the power is 1. If all the powers are odd, it has to be an odd function. If all the powers are even, it will be an even function. And if it is a mix, it is neither even nor odd. So it doesn't really matter what k is, because k is, after all, a constant. So that guy is not really going to change its behavior. So this will be odd for any real k. It doesn't really matter what k you want to put in, because we are only changing the sign of x. We don't really have anything to do with k. If you're thinking that if we make it negative, that things will change, it won't. I can give you an example. Let's make it minus 1. And let's replace x with minus x. So all the x will become negative, right? Since the powers are odd, negative will be thrown outside. So it will become like this. And let's take one negative as a factor. And don't you think this is same as your function? So you are getting f of minus x is minus of fx, which is the property of an odd function. So the answer is C. I hope these questions are making sense. In case you need further help in private tutoring, feel free to reach out. Okay, consider this polynomial, and we have to find again which of the following is true. Now, notice carefully. This is a combination of even powers and odd power. Given that if k is not 0, if we make k as 0, then yes, this will become an even function, which option B is saying that if k is 0, it will become an odd function, which is absolutely wrong. If k is 0, this will definitely become an even function. So, well, B is gone. Is there anything else that is talking about k equal to 0? No, the others are talking about k not equal to 0. Okay, the first one is saying that it will be an even function for all real k. Well, that's not correct. For if k is not 0, then it is basically a combination of even powers and odd powers, which we just discussed will be neither even nor odd. So that's not possible. Option D is saying that g is odd for k not equal to 0. Well, no, we just discussed that if k is not 0, if k is something, if this term exists, then this guy will be neither even nor odd. So that is wrong. This makes sense that k is neither even nor odd for k not equal to 0, and limit x approaching negative infinity is infinity. Yes, because it is an even power, the degree is even, and the leading coefficient is positive. So it should be option C.